Welcome to a rapid mechanics formula review. We will organize the essential equations by topic. First, kinematics. Velocity is change in position over time, acceleration is change in velocity over time, and for constant acceleration, v equals u plus at, s equals ut plus 1/2 at squared, and v squared equals u squared plus 2as. For two-dimensional motion, resolve vectors into components, and projectile motion uses x equals v0 cosine theta times t and y equals v0 sine theta times t minus 1/2 gt squared. Newton's laws give net force equals mass times acceleration, weight equals mg, friction is at most mu n, and spring force is minus kx. For circular motion, centripetal acceleration is v squared over r, angular speed is v over r, and centripetal force is mv squared over r. Work is force times displacement times cosine theta, power is work over time, kinetic energy is 1/2 mv squared, gravitational potential energy is mgh, and spring energy is 1/2 kx squared. Momentum is mv, impulse is force times time and equals change in momentum, and momentum is conserved in an isolated collision. For rotation, angular velocity is change in angle over time, torque is r cross f, rotational kinetic energy is 1/2 I omega squared, and angular momentum is I omega. Universal gravitation is g times m1 m2 over r squared. Orbital speed is the square root of gm over r, and escape speed is the square root of 2gm over r. Finally, simple harmonic motion uses x equals a cosine omega t plus phi, with omega squared equal to k over m for a spring and 4 pi squared over t squared for the angular frequency. Keep units consistent, draw a free body diagram, and choose the equation that matches the physical situation.